There we go. Now, if this is not enough space, you can always write it on another piece of paper, but this should be pretty good. Okay. But just start off with what do you got to do to top and bottom each fraction to get them all to match. That's the name of the game. Alright, so let's start over here. First of all, looking at all three of these, what would the GCF be, or LCM be? What would make all these match? Okay, so 4x, I'm hearing. So this one would need a x over x, right? Now this is 4x, that's 4x. And this would need a 2 and an x. So that's step one for each one of these. Just figuring out what is the GCF. LCM, I keep mixing those up. I'm just going to do the first step on several of these. So like on number 3, you can see it's just going to be x squared, so multiply each of those by x. Now they're all x squared. Now when you get down to here, down to 5, you can see that before they were all factored because it was just monomials, so by definition they're factored, but when they got polynomials, they can probably be factored. So the first thing you want to do is go through and factor them. We can't just say I'm going to multiply. And these are identical. So, and chances are, again, use context clues here. Chances are, if this one is x plus 6, one of these is going to be x plus 6, right? To make all this work. So if you start off with x plus 6, say, okay, what multiplies to 12, adds to 8, and one of them is 6, so it would be 6 and 2. 6 times 2 is 12, 6 plus 2 is 8. It gives you a little hint on how to start out. You don't have to do it completely from scratch, although it's not super difficult to figure out 6 and 2, but helps to know. And then we can see, okay, over here, now we can add what we need. We need to put on, what's missing? X plus 2. Here, plus top and then bottom. And since it's 1 on top already, we're just going to have x plus 2. So that's the first step on all of these. Notice how I had to factor a trinomial here. If you go down to the next problem, it's more GCF work. So you have to factor out an x. Right? So factoring could mean do the x, what multiplies to this adds to this, but it also can mean factor, do a GCF. Same thing over here. What's the GCF of the last term? 3 and the x, right? Both. And then what's left over? X minus 3. And now we have to figure out, well, what's the GCF? LCM, sorry. GCF. So to get all these to match, multiply this by 3. Right, so now it matches over here. Gotta do the same thing on the top. Make sure you put in parentheses right here. Big step. Gotta put parentheses. Alright, and what's missing over here? 3 and the x. Good. Flip it over. Alright, you guys go ahead and try this one. See what you come up with. Just do the first step like we did on the front side. Just figure out what you would multiply top and bottom only. We'll go through and solve them in a minute. So first one, multiply by 2n, right? Okay, good. So that will match 4n squared, right? So same thing on the top. What's missing on the top right now? What else do we have to do right here? Parentheses, yes. If you don't do parentheses, it will mess it up. So parentheses, good. Second one, second term? 4n. And then once again on top, 4n parentheses. And last one? Nothing. Yeah, we're good. So two things going on here. Of course, what to multiply top and bottom. And when you have anything more than a binomial or above, make sure you use parentheses for the distributing. Okay, good. Let's try another. Well, this one's kind of easy. Yeah, first one's just got away with an easy one. Good. Okay, now we get down to here. Yeah, so think of this as minus 1 over 1 if you have to. Right? We can make it x minus 5 top and bottom. Lastly, okay, factor. What do we got? GCF here? Squared, right? And these are identical, so they're going to be the same. So what's left over? P plus 6, yes, P plus 6. So what's missing? Yeah, P plus 6. So factor and then match them up. And again, need the parentheses here since it's a binomial on top already. So we're going to actually have to FOIL this together in order to solve this problem. Alright. So really that's the hardest step. Really those two things. Factoring, figuring out what to make them the same, and then these parentheses to put them on. Anytime you have to multiply on top and there's already like a binomial there, like an n plus 2 is already there, make sure you put that in parentheses. 3x plus 6 already there, put that in parentheses. It's the little things. It's not big steps, big concepts, it's little stuff. Again, on the front, they should all come out to linear, meaning when you're solving, no squareds or anything. Alright, so let's figure this out. Alright, the next step, since all of these match right now, what you do is you go through and you multiply by that same denominator we just figured out. And by doing it, if we distributed to each one, it would just cancel out the top and bottom. So in effect, when you multiply by the 4x, it just cancels all of the fractions out. There's no more fractions. So you're just left with whatever's on top. So whatever's here, right there, that's what you're going to be solving. So in this case, it's like 1 plus 2x equals x. And then you can do the steps to solve that. And one equals negative x, so negative 1 equals x. And this is an equation. So for the diehards that you're going, I really need to do well, I really got to pass this class. I really got to make sure you can go through and check your answer, plug in the variable into the original one, not anything we crossed out, but to the very original one. So, wait a minute, that's not right. Like, yeah, plus. So does -1/4 plus a half equal 1/4? Or does a half minus a fourth equal a fourth? Sure does. So you can do a check. Anytime you have an equation, you can do a check and see if your answer's right. You don't have to turn it in and hope it's right. Okay, good. Let's just move it on. Okay, multiply by what? What's the denominator? X squared. That cancels that x squared, this x squared, all of them. And our equation is just whatever's on top. So we have 2x minus 1 is x. And I'll let you solve it and get your answer. I think the answer is 1. Yeah. X equals 1. Okay, good. And it's the same thing here. We're technically multiplying everything by x plus 6 and x plus 2. Okay. When I distribute that x plus 6, it'll cancel each one of those. And when I distribute that x plus 2, it cancels each of those. So our equation is 5 equals 6 minus x plus 2. And technically it's 1 times x plus 2. Now these negatives right here, which look like minus signs, can be tricky. All right. So make sure you distribute. Order of operations. Minus x, minus 2. Okay. Then solve it. Okay. So distribute. And I did 6 minus 2, that gave me the 4. That's all combining like terms since they're on the same side. And then I, subtracted 4 both sides. And then divide by -1 both sides. Okay, so I got x equals -1. So it's weird because these problems look like big fractions that are super hard, take forever, but really after the first or second step, there are no more fractions. Most of the work is this, solving a pre-algebra, algebra 1 equation. So, mathematicians are just like everybody else. Fractions? Nope, let's find a way of getting rid of all the fractions because that's hard to work with. Alright, good. Almost there, a little bit more. Let's try some of these. Now there'll be quadratics, right? So multiply by that denominator, whatever it is. Keep in mind this step right here, I see this on the test sometimes. We can only do this when we have equations. So like what you have right now, this doesn't work clearing out the fractions. Only works when you can do it to both sides. So cancels all of those out. They're all the same. Notice how they're different forms of the exact same thing. 4n squared, 4n times n, 4n squared, 2n times 2n, 4n squared. Okay. Now there's a lot more to solve that's left on top. So here we go. 2n times n, 2n times 2. 2n squared plus 4n. Good. 4n times n. 4n times 2. Lost my equal sign somewhere. There it goes. Did it again. That's the equal sign. And then plus n squared minus 4n minus 12. So I got all this stuff right here that's similar. So I got like a right there. That's going to be a 5n squared. I got an 8n and negative 4n. That's going to be a 4n. And then a minus 12. That just comes down. This side can't combine anything. Let's bring it down. So you can see a little bit more work now to solve since they're quadratics. So with linear, you get the variables on one side, numbers on the other. But remember, with quadratics, you have to get it equal to 0, and you could factor it or quadratic formula or anything. These are all going to be factorable. They're not going to have to do quadratic formula or anything. So subtract your squares. So subtract squares from each side. Subtract the 4 n's on each side. 0 equals 3n squared minus 12. And go ahead and solve that by factoring. What's the GCF? Divide both sides by 3 here. That cancels that out. 0 divided by 3 is 0. So if I actually showed that, right, they just cancel out. So now you're just left with yeah. So a little bit more work to do with the quadratic side. And what does this factor to? N squared minus 4?
N plus 2n minus 2.
N plus 2n minus 2. Okay. So n equals 2 and negative 2. So oftentimes 2 answers, right, with quadratics. A lot going on there, right? Okay, a couple more. Continue maybe you can go a step ahead of me and just check up and see if it's the same thing you have. See if you can get the hang of it on your own. See if you can write out the equation for this one. It's nice to see somebody else do it, but in the end, it's if you can do it on your own. So try it on your own using these. So far, you probably got a good rhythm right now, a good habit. So try it on your own. Have some trust in yourself, and when you get the equation, just stop and you can check with me. go. And so, did you get this equation? 5p squared plus 4p minus 9. So combine the like terms. Negative 10 plus 1 gives me the negative 9. They're on the same side, so I didn't subtract 1 on both sides. I didn't add 10 on both sides. Right? These are on the same side already. You just combine them. Simplify it. Okay, here, the p is on both sides. Trying to get it equal to 0. Subtract p on both sides. 5 minus 1 is 4. Okay. Now we got to go. So what two numbers multiply to negative 45p squared and add to 4p? 9 and 5. 9 and negative 5. So multiply those, you get negative 45. Add those, 9 minus 5 is 4. Okay. Now be careful. Don't take this and say, okay, it's p minus 9p and p plus, we have to put this in the box. Factor it properly. So I'm going to go up here. So we have 5p squared. We got negative 9. And from my x here, in any order, 9p and negative 5p. So we have, let's see here, GCF of each one, and go through and get your 2. It's nice, a lot of these problems have a lot of review built into it, so you don't forget some of the stuff where it came from. How come we have, or when do you know you have to do this box? Yeah, so because this is something other than 1 right here, this is just p squared plus 4p and so on, I could just take those two right from here and go straight to the parentheses. But because of this, that's why I have to go to here. So the next problem may not have this. So just gotta watch. So GCF of each row and column, we got p, we got 5p. We have a negative 1. They both have a negative in common, take it out. And then they both have a 9 in common. So whatever they have in common, numbers, they both have a 5 and they both have a p, so I took out both of them. So make sure you got both. And then p minus 1 equals 0. 5p plus 9 equals 0. P equals positive 1. 5p equals negative 9. So p equals negative 9/5. 2 answers. And if you want to summarize it like this, that's fine. Awful lot going on. And then, of course, what's coming up after this, which is tomorrow, is we'll be graphing this. We'll be graphing and see what this stuff looks like, and where did these numbers show up on the graph? Excluded values, what did they do? You remember we can't divide by 0, so we have excluded values as well, and we'll look at what those look like graphically. So on a test, it's not like you're going to have one of these just, well, you might have one of these just by itself, but most of these are going to be solve it and then graph it and then make sure your answers here, that you get when you solve it also match the zeros that you get on when you graph it. So just like quadratics, when they cross the x-axis, they have to agree with one another. All right, let's see here. I think we'll skip 13 for now, because that one's a little bit, no, we better not. There's one little thing on here that worries me. That's the minus sign. So multiply by x minus 5. That cancels all of these out. And this is the part that worried me, why I was like, let's not skip this. If you're not careful right here, this negative can get away from you and you can forget about it, so make sure it's 1 minus x plus 5. It's so frustrating to do all this work and then realize at the very end, I just missed it because of something small, like a little negative. And then go ahead and solve. And this one looks like, since it's a 1x squared, you won't have to do the box and everything, so a little bit easier, factoring wise. And then lastly, multiply by all of it. Yep. Cancels all of it out. So just p plus 4 equals p plus 2. And right here, 2 binomials. This is the only problem that has 2 binomials. Well, this one and the next one. So it's going to be plus p squared plus 6p plus 5p plus 30. And then get it all equal to 0. Again, this is a little bit easier since the p squared is 1p squared, so the factoring will be easier. You don't have to do the box on it. Okay. There you go. So that's everything you need. Do you want to solve these, or are you guys good? I think you guys are good. It's a lot all at once. If you get stuck, well, you have a good example directly to the left. So if you get stuck on number 2 or number 6, just look to the left and you wrote down a good example of that problem. Otherwise, you can just pull up the video and maybe rewatch it. Maybe that helps sometimes. Pull it up on your phone. Okay, good. I'll let you guys maybe spend the rest of this period just finishing these two, the 13 and 15. Just finish those up. And then for homework, finish up the other side. This will take some time, and this will be a lot of points. I am not accepting anything late. So whatever you walk in with finished at the beginning of the period tomorrow, that's what will be scored. And if you just come in half done, or I just have to do this, okay, remember this is the end of the year. There's no something to bring it up because you're getting lazy in May. So make sure you do spend the time to get it done on time. We only have a few more weeks of this, and then we're done. Really, 2 more weeks of homework. The rest is review. So this is not a good time to, oh, that's too hard. I don't think I want to, and I'll just do more work later. There is no later. So make sure you get it done before you come to class. I will be after school till 4 o'clock too if you need help, or if you just want to finish it and go home and have it done.